My name is Tim Stewart. I have with me today Bob Sloma from Sandalwood Engineering and Ergonomics. Today, we're going to be talking about implementing Industry 4.0 solutions in manufacturing. I'm going to go through about 15 minutes of slides up front, and then I'm going to bring in Bob, and we'll have a conversation about Sandalwood's experience implementing these solutions in manufacturing as well. So with that, I'll go ahead and get started. Just as a quick procedural note, if you have questions, please go ahead, put them into the chat, put them into the Q&A, and we will answer them at the end of the webinar. So first of all, I want to clarify what I'm talking about with Industry 4.0. The graphic on the right side there comes from the World Economic Forum, and Industry 4.0 covers a broad range of different technologies and solutions. For my purposes for today, what we're going to be talking about really centers on some of these solutions I have highlighted over on the left side with IIoT, advanced analytics, machine learning and AI, augmented reality, that class of solutions. So in terms of implementation best practices for those particular smart factory types of solutions, there are several topics and themes that I'll be touching on as I go through the presentation today, and then talking with Bob later. First of all, we want to begin with the end in mind. Borrow that obviously from Stephen Covey, but you have to understand where you're trying to go, what you're trying to do with this. You basically have to define the problem before you can go ahead and try to solve it. And then the next step is you can't make a big difference in this until you actually focus on the culture and the process. Just putting the technology in alone is not going to solve all your problems for you. And then utilizing agile techniques to go fast and get quick results. So with that, I want to start with that idea of beginning with the end in mind. And for the visual decisions approach, the way that we look at these different projects is we actually start with what is that kind of top-down benefits case? What are the primary things as a business that you're hoping to achieve? Are you trying to get more throughput? Are you trying to reduce your costs? Are you trying to improve your quality, faster time to market? What are those top-level objectives? And then we ask the question of what are the impediments to that performance today? What are the things that are standing in the way of achieving your goals? Then we do some level of root cause analysis on that, maybe not down to the absolute detail, but getting to a point where we find an actionable cause that we can address. From there, we start to look at what are the different capabilities, business capabilities that you would want to put in place that would address those things. And so how do you want your quality department to function differently in order to address those quality issues? How do you want your maintenance department to change the way that they behave, and your engineering support and so forth, to keep the machines running more effectively? And then from those business capabilities, we start to look at that Industry 4.0 toolkit and say, what are the enablers? And what are the enabling technologies that we can put in place that will support those business capabilities that will address those root causes? And once we have that determined, that essentially defines our roadmap for us, but it also helps us map all the way back to how are we going to drive the value for the project? And so there's an entire path through that, but what that allows us to really do is to focus on that impact to the financial performance that we're trying to drive, whether that's increasing revenue by increasing our capacity, or whether it's reducing various forms of expenses, reducing inventory, avoiding capital spending on plant, property, and equipment. Those types of things are what really drive the ultimate success of the project. Next, as much as I'm obviously a fan of smart factory solutions, the technology alone is not enough. And the analogy that I use all the time is a Fitbit. I've been wearing a Fitbit for 9 years now. And unfortunately, I've gained 20 pounds during that time. And it's not the Fitbit. It's not the Fitbit's fault, I should say. The Fitbit works great. It does exactly what it's supposed to do, just like these technologies, for the most part, do exactly what they're supposed to do on the shop floor. But with the Fitbit, I haven't changed my behaviors. I haven't exercised more. I haven't eaten better and so forth. And so I haven't lost the weight. So even though the Fitbit, has those advanced sensors, it, grabs that information directly from my wrist. It, pushes that information to a cloud-based application. It has advanced machine learning capabilities there that take those raw signals and turn them into footsteps and heartbeats, pretty charts and graphs that, present all of this information to me. And I still, do the same things tomorrow that I do today. Well, I'm not going to lose the weight. And it's the same thing on the shop floor. So when you put these IoT systems or anything else in place, you're going to have all kinds of information that you've never had access to before. But just having that access, having those pretty charts and graphs, is not going to automatically make the process run more efficiently. You have to think through, what are your people going to do differently tomorrow than they do today? And so part of what we help you with, and part of why I partner with Sandalwood in these efforts, is that we really think through the human aspects of this. How is your quality department going to do their jobs differently once they have this information available to them? How does your continuous improvement team change the way that they do Kaizens and root cause analysis and so forth in order to take advantage of all of this additional data? And so those are the things that are really going to drive the success going forward. And so the next step is looking at who needs to change. And very often when we think of these projects, the first thing that we think of is, well, the operators have to put in data, or they have to, respond to these visual controls that we're putting in the factory and so forth. And that's absolutely true. There needs to be a focus on the shop floor. The operators, the supervisors, production management, have to make this part of their daily standard work and their daily accountability to really make these things run smoothly. But you really can't forget the support teams either. Manufacturing engineering needs to be, or process engineering needs to utilize this information to really look at where the problems are on the shop floor, what the drivers for those issues are, and now putting steps in place to either mitigate or eliminate those errors. Identifying the waste in the process and being able to utilize this information to not only find that waste, but figure out how to eliminate it in the future. My quality department needs to utilize this data to identify the root causes for variation in the process, and looking at things like vibration and sound analysis and how that correlates to the quality issues that I'm seeing in my SPC charting and so forth. And then maintenance and facilities, using this information to keep the equipment running much more effectively through techniques like predictive maintenance or condition-based monitoring, instead of just doing reactive maintenance in the future. IT needs to help support this process. You have to have the bandwidth on the shop floor. You have to have the internet connections and so forth to make all of these sensors work. And IT has to provide that backbone to support all of these systems. And furthermore, IT should understand more about the shop floor than in many cases they do today. I've walked into plants where we did a presentation and we had IT walk through on a whiteboard for us what are all the different systems that they have in the company. And they drew up their ERP system and their business warehouse and engineering design systems and so forth. And then they went and sat back down and I was like, where are the plant systems? And he went back up and drew a little box and said plant. And that was all he knew, because he hadn't actually been to the plant before. That has to change. These systems need that information technology support. It has to be embraced, and they have to start to understand, what are the different things that they can do to support production in these systems on the shop floor. But I think even most of all, management has to embrace and lead this change. Where I've seen this be most effective is when the plant manager actually has a display in his office and sees these things happening in real time on this display board, and makes that part of his job to now utilize that information to work with his people and really drive attention to these details from that top down. In terms of the scope of change, real quick story here. I did Industry 4.0 implementation across this company, and one of the plants just put it on one machine. And they wanted to make sure that the technology worked in their environment and that they were going to get value from it, which makes total sense. But because they only put it on one machine, their people didn't really make it part of their job. I mean, they rotated people, and so the operators didn't really pay that much attention to it because they worked on 5 different machines and only one of them had this technology. The quality department, the engineering group, and so forth didn't pay any attention to the data because it was just on the one machine. And so when you're looking at these different things, it's fine to dip your toe in the water and see if the technology does what it says it's going to do. But at some point, if you want to actually cool off, you have to jump in the pool. And it's the same thing with these different technologies. You have to implement it broadly enough that it really becomes part of everybody's daily jobs. And if they don't have that view that this is what they do, this is how they do things in the future, then you're not going to get the value. Next, you have to communicate more than you think you have to. The first real issue is overcoming the big brother problem. When you implement these technologies on the shop floor, there's going to be a natural reaction of people that you're monitoring them instead of the process. You have to be very clear in your communication with them that you're not putting this in there to beat them up. You're putting this in there to make everybody's lives easier. And the second thing is with the support staff. As I mentioned a little bit ago, these people really need to be able to use this information to do their jobs differently. So as you're communicating through the project, you need to make sure that you're communicating with them how their jobs should be done differently in the future based on having these new capabilities. Next, operational excellence and looking at kind of a lean management system or a lean toolkit 4.0. How do you incorporate all of these different technologies into the way that you do operational excellence? And I've got a ton of webinars on this information. I encourage you to go to my website, take a look at those. But that is absolutely critical to the success as well. When you're looking at the different performance metrics and the data that you're trying to collect, whatever processes you have in place to make things better, make sure that you're aligning the data that you're trying to collect, with those different processes. So if you are focused on TPM or total productive maintenance, make sure you're pulling in data that's going to support your control towers and so forth. And so just make sure that you drive that alignment. Next, in terms of Agile methods, as you're implementing these solutions, Agile will absolutely help you out with this. Part of change management theory is to be able to generate quick wins. One of the primary advantages of implementing with an Agile methodology is that you start to see results as soon as you have that minimal viable product in place, and then you continually improve upon that. And that mindset fits in so well with the continuous improvement mindset that's prevalent in manufacturing, and it really helps with that adoption. So I can't recommend Agile strongly enough when looking at these implementations. So with that, apologize, I went pretty quickly, but I wanted to make sure that we had time for our guest today. So with me today, I have Bob Sloma from Sandalwood Engineering and Ergonomics. Bob, can you give a quick introduction to yourself and Sandalwood?
Yes, Tim. So I have well over 25 years of experience in manufacturing, starting as an engineer, moving into engineering management, and eventually, moving into a corporate IT role where I interfaced with manufacturing plants around North America. The last 3 years, I have been working with Sandalwood and mainly with a major automotive manufacturer as a client, working in their advanced manufacturing center, and spent significant time working on their industrial cybersecurity efforts, and then eventually moved into they started their effort on IIoT. So got to do a lot of work on investigating different ways of gathering data using newer technologies and in some cases open source technologies to get data from machine PLCs and moving that into an environment that IT systems can then pick up that data. So Sandalwood is involved, is an engineering services company.
Mm-hmm.
We work in process improvements, ergonomics, obviously, and safety, and systems integration.
Okay. So in terms of implementing these different systems, I know that I've worked with Sandalwood on a number of different projects in the automotive industry as well as other industries. And I wanted to spend some time with you today talking through, your experience and Sandalwood's experience and how this really can be done with different customers. So as a first question for you, I know that you have a Six Sigma background. So I was wondering, how do you think that customers can take advantage of some of these new data capabilities in their operational excellence practices?
Sure, Tim. So the way we view it.
And 1 second. In the chat or Q&A, I'm hoping that someone in the audience can let me know whether you can see Bob's screen or not. Because it popped up on a different monitor for me. So I'm just, okay, excellent. So people in the audience say that they can see your screen, Bob. So sorry for interrupting. Go ahead and present your slide.
There's three main, categories, at least from our perspective, when you're actually trying to do, implement some of this technology. First is being able to capture the data, then doing analytics on that data, and from the analytics being able to generate actionable insights. And there's different levels of maturity, but on the capture side, first step is just getting the raw data in the first place. And Six Sigma needs, Six Sigma processes or techniques, raw data is what drives those. So being able to gain access to that data. And then you also need to have a data or an information model that you're working to be able to map that data to and label it in a standardized way. And in some cases, you may have to normalize or transform that data to be able to map it from PLC tags into a standard format. Then on the analytics side, you oftentimes can, in addition to that raw data and labeled data, you'll need to calculate some values, averages, and things like that, or be able to generate trends. So you'll need to, and also the ability to be able to do visualization of that data becomes important. As you move further along in terms of maturity, being able to use all of that data, the calculated values, the trends, the raw data, to feed machine learning and AI models. On the actionable insights, some of the, in addition to andon boards, andon or display boards, being able to set up alarming systems is a good first step. As you start moving further along, utilizing some of the ML and AI techniques, you can start to get into predictive maintenance. Also being able to do prescriptive actions, so based on trends or in the data for your manufacturing process, be able to tell operators to do certain things to keep your processes in control. And then even further along, being able to automatically make process parameter changes to actually feed commands and data set points and stuff like that back to the PLCs from an ML or an AI model.
Excellent.
And a lot of that, especially in the analytics, a lot of the Six Sigma techniques are really required for someone to go through to be able to create data sets for machine learning and AI. So basically, you can, and it enables you to use those techniques and what you've learned from your Six Sigma activities to sustain those improvements over time, which tends to be an issue in many companies, that over time the operations tend to go back to what they used to be when the focus wasn't on them so heavily.
Absolutely. My webinar next week is actually on titled Fighting Performance Entropy, which is just kind of a fancy way of saying the same thing. That I had a customer once with a very large company that headed up their continuous improvement practice. And he said that if they could just save all the improvements that they've made over the years from all their different Kaizen events, you could basically just drive the truck past the plant and everything would spontaneously assemble and fly into the back of the truck. And the sad fact is that, once the team leaves that improvement event, you do have that entropy. If you don't keep a light shining on the process, essentially, that performance gain that you've managed to get kind of withers away over time. In terms of some of the data usage and so forth, one of the things that I've talked to customers about sometimes is when you're doing a Six Sigma event, very often you'll end up wanting to do a DOE, a design of experiments, or an ANOVA, or some statistical study. And usually what that means is that you have to start gathering that data at that time, kind of going forward and looking at that information. Is there an advantage, and is there a possibility to, if you've been doing the data collection and you have a lot of that data already there, to kind of do that design of experiments on some of your existing historical data to speed that process up? Yes,
definitely. And once again, if you've set it up in such a way that you're persisting that data in a database or a data lake, which you definitely would want to do for ML and AI type projects, it's available there for future study. And once again, as I mentioned before, a lot of the techniques for building ML and AI models are very much are very similar to and use some of the same tools that Six Sigma does.
From an implementation standpoint, does that kind of imply that when you're looking to connect different things and what information you should save and archive and so forth, that essentially, even if you don't see a current use for that information, that it might be helpful to kind of grab as much data as you can, or at least as you can reasonably store. And that way, if you're trying to do an improvement event in the future, you might already have the data that you need for that event, even if, a year ago you didn't foresee the need for that information.
Yeah, but that's one of the challenges too. How to, if it's easy to collect, you might as well grab it, even if you don't have a use for it today, because it may be useful in the future. And if it has any chance of being able to pick up changes in your manufacturing process, it's worth grabbing.
Yep. Another use that I've seen for that type of thought process is when you're looking at warranty items or recall items and things like that, being able to see what happened on the shop floor when those items went through production, and being able to do kind of a root cause analysis on some of those items that may come back in the future, as opposed to what's happening on the shop floor today. Is that something that you've seen at your customers as well?
Yes, definitely.
Okay. So we've talked about how you can utilize some of these new data capabilities in operational excellence. How about the flip side of that? How is it that you can utilize some of these operational excellence practices to better implement the smart factory?
Well, that comes down to you really have to understand your processes, right? And from in Sandalwood, we're very process oriented. So being able to understand what your current state is, both from a business process, a manufacturing process, and all the data points and supporting systems that are involved, and how that data moves between systems is really important. And oftentimes we'll utilize partners like yourself to handle some of the initial steps of linking the business goals and the operational goals, and doing some of that current state mapping. But when you get into the future state mapping, it definitely makes sense to bring somebody like Sandalwood in to be able to determine what the art of the possible is. And oftentimes we'll take a look at what we can utilize that you already have in place today, but then enhance those with some other technologies, and be able to help map out what that future state looks like. Because, and as you mentioned, if you're going to change operator processes, or what data you're collecting, you have to change the culture around it, right? So you had to change your supporting business processes and day-to-day activities. So being able to define those as part of your future state is important, as well as, how is data going to flow? What changes are you need to make to your operator screens? Maybe what you display on your and on boards are going to change.
Yeah, I mean, that's critical for establishing those positive feedback loops with visual controls out on the shop floor.
Right.
It's kind of funny when you think about what you've laid out here for implementing these systems is very, very similar to a typical flow for going through a value stream mapping process and so forth, where you do that current state mapping, the future state mapping, looking at how you're really going to improve the process and so forth.
Right, and then that eventually feeds into projects, right? That you can define their scope, stakeholders, the budget, the timing, the expected results, and then move into the execution phase, where you actually do the design and documentation of what the new business processes and operational processes will be. Design the systems around that. And then move into implementation, in which training is very important. And then the other aspect is to actually come back in and take measure, look at your measurements, your KPIs after the fact, and compare the results to what your objectives were. And then don't forget to celebrate at the end.
Yeah.
And if you didn't quite meet your objectives, it still is, your celebration can also be part of a lessons learned activity.
Absolutely. It's interesting that you have the celebrate step there, because if you look at different behavioral models and how to establish new habits, that celebration step and acknowledging the achievement and so forth is actually critical to establishing new habits in your own personal life and so forth. And from an organizational perspective, I think it's also important, and it's great that you put that there, to celebrate those achievements in order to really help to establish that new path for the organization.
And it helps with the sustainability.
Right. One last question, then we'll answer some of the things coming in from Q&A from the audience. Some of the processes and information and data tend to be siloed in different operations. How do you kind of democratize the access to that information and so forth?
So part of that is to utilize standard communication models and utilizing some of the newer ones, like the pub sub protocols like MQTT and OPC UA. To transmit data from the factory floor machines is a good first step, because then that enables the ability to have other systems subscribe to the data flows, to collect that data and communicate back to the factory floor machine. And it also provides a means to send data to a common database or data lake in a common and standard format, which then allows you to increase access to that data for further analysis and development of future decision support systems, or to do root cause analysis like we talked.
Excellent. Thank you very much. I know that we're a few minutes over our normal time here, but we do have a question from the audience from Emmanuel. So Bob, along with the machine data that you've extracted to correlate to measure productivity, or have you extracted your business data to correlate to measure productivity? And if so, can you briefly talk about the integration and the tools used from an analytics standpoint? So I think that what the question is getting at is, once you've extracted the data, for the different customers and so forth, what are some of the tools that you or your customers at Sandalwood have utilized to provide analytics on those solution or on that data?
That's a good question.
Yeah, and I mean, I know it was addressed to you, but I'll shoot out some answers here as well. I know that together we work with PTC and ThingWorks very frequently in terms of doing implementations for different customers. And so that's certainly one option in terms of different IoT solutions that are out there. There's a number of those. From an OEE perspective, if you're looking primarily at machine information, there's a number of fantastic OEE solutions that are out there today. And then once you've extracted all of this information, pulled information from your business systems to marry with it and so forth, you can utilize reporting systems as well, such as Tableau or Power BI or Click or any of those reporting solutions to look at some of that archived information and create analytics workflows for those things as well. And you can even push this information to a system like R or MATLAB or any number of different solutions like that to be able to use this data to produce other types of analysis and information. Really getting the data is the first step, and then there's a number of different ways that we've seen our customers utilize that information to perform analysis.
Yeah, Sandalwood's software agnostic, so oftentimes we'll use whatever tools the customer is comfortable using or is already using today. I know personally, I use a lot of Python libraries in some of the work that I've done in the past. So there's all kinds of and scatter plots and all that fun stuff.
Yep.
So
excellent. Well,
getting the data is half the battle.
Yep, exactly. I know that we've gone over, and I know that you have some other commitments today, so I want to thank you, Bob, for your time, and thanks to everyone that joined us today. Let's see. So if anyone has questions, please feel free to reach out to me at tim@visualdecisions.com. And Bob, do you want to give your contact information real quick? I should have put that in the presentation, but do you just want to share your email so that people can reach out to you?
Yes, I can be reached at r.slumma, S as in Sam, L-O, M as in Mary, A, at sandalwood.com.
All right. Thank you very much. And thanks to everyone that joined us today. The recording will be available on my website, YouTube, and I believe that Sandalwood will also make the recording available in the future. Look forward to talking to everybody and how we might be able to help with implementing Industry 4.0 in your companies as well. Thank you. Bye-bye.